Yes, morning all of you. I'm sorry that I am disturbing you again. Now I am going to demonstrate you important steps in your organic compound analysis, where usually students are struggling, where usually the students are incomplete, I can say. As a result, they are usually failed in completing their analysis. Number one, the moment you receive your organic compound, say for example, I have an organic compound. This, with the help of this, I am going to show you how to confirm the presence of aromatic or aliphatic. The given compound is aromatic or aliphatic. This is the Bunsen burner. This is the Bunsen flame. Actually, this flame is called Bunsen flame, and this burner is called Bunsen burner. With the help of this Bunsen flame, I'm going to show you how to confirm the presence of organic, that is aromatic, in this given compound. Take a small amount of the given organic compound in a clean spatula and introduce this compound very close to the blue edge of your Bunsen flame. See what happens. The compound catches the fire and immediately start burning with a lot of luminous flame or sooty flame. See the smoke that is coming out of this organic compound. Yes, this is that. This is your luminous flame or sooty flame with a lot of carbons that is coming out of this compound. Once you get this result, this confirms the presence of aromatic, the given compound. As a result, you are confirming that the given compound is aromatic. Otherwise, the compound is aliphatic. Right? I'll show you again. Just for your confirmation, just to clear your doubts, take a small amount of your organic substance given, and the compound taken here is solid. You may get the liquid also. That also you take here. A little of the liquid given. If the compound given is liquid, you take little amount of the liquid, that is organic compound, and introduce very close to the Bunsen flame, that to the blue edge of your Bunsen flame. It will definitely catch fire and start burning with lot of sooty flame. Smoke coming out of this flame. This flame is called a luminous flame or sooty flame. See what happens here? This confirms the presence of aromatic in the given compound. So with the help of this, you are confirming the very first point in your analysis, in your aim of this analysis. What is your aim of this organic compound analysis? What are the things you are going to confirm? Number one, whether the given compound is aromatic or aliphatic. I will show you just, I showed you how to confirm the aromatic or aliphatic. Number two, whether the given compound is saturated or unsaturated. Number three, whether the nitrogen is there or not, that is elements in general present or not. Usually we have nitrogen, chlorine, bromine, iodine and sulfur usually will be given, and since in your level, that is in the BSc level, we are not giving you the halogens in general, only the nitrogen we give you, and this presence of nitrogen you are confirming with the help of a special test called sodium fusion extract test. I will show you very shortly how to perform this particular sodium fusion extract test. And after that, as usual, the presence of functional group in the compound. So the confirmation of your saturation or unsaturation, aromatic or aliphatic, and the presence of nitrogen or not in your given organic compound is very simple. I will show you one by one. Just now I finished how to confirm the presence of aromatic in the given compound, whether the compound is aromatic or aliphatic. So with this, I am closing the demonstration on how to confirm the presence of given compound is aromatic or aliphatic. Now I am moving my discussion, demonstration, to confirm you, to show you whether the given compound is saturation or unsaturation. Take the same compound in a test tube, little take to this, where is distilled water? Now, I have taken a small amount of organic compound to this I'm going to add little extra of your potassium permanganate, not too much. Just I have taken in milligrams of the given organic compound, small amount of organic compound. To this I am going to add potassium permanganate solution. See here, the color of potassium permanganate is dark blue in color, something like. Try to shake well and see the result, whether the color of potassium permanganate remains or disappear. This is the observation you have to follow. This is the step you have to follow. The inference after shaking vigorously, after taking the compound with your potassium permanganate, this is the result you are getting. The result is the color remains. There is no change in the color. There is no change in the color. As a result of this, you are confirming that the given organic compound is saturated. The given organic compound is saturated. I will show you one unsaturation. Baba, cinnamic acid, please. Cinnamic acid. So this is the compound taken here is, with the help of this, you are confirming that the conclusion, what you get, what you arrive here is the given organic compound is saturated. Now I am going to show you the unsaturation, the result of unsaturated compound. Take a little of the given organic compound into a fresh, a clean test tube. To this add same potassium permanganate, little extra as you did previously. You better use your dropper tube and see what happens. See here, the color disappeared. Original color is not this one. See here, change of color has taken place. Color disappeared. The original color of potassium permanganate is disappeared because the organic compound that I used to carry out this analysis is your cinnamic acid, which is unsaturated compound. C6H5CH double bond CH COOH, monocarboxylic unsaturated aromatic acid is nothing but your cinnamic acid. Whereas the previous one that I have used to confirm the presence of aromatic compound is saturated. For that I have used your that is phthalic acid. Phthalic acid is your saturated acid, a dicarboxylic acid, whereas the cinnamic acid is unsaturated monocarboxylic acid. This is unsaturation. Now I want to tell you one very important thing with respect to the saturation and unsaturation. The inference, what you inferred at this moment is the compound, one compound is saturated, another given organic compound is unsaturation. Tell me, what for there is a change in the color if the compound is unsaturated? What is the reason behind the color remains in the case of your saturated compound? This you should understand. Being a chemistry student, you should know the reason behind why in some compounds, why in some that is organic compounds, the color of potassium permanganate, the moment we add and shake, the color disappears. What is the reason behind? Some compound keeps the original color of potassium permanganate. Some compounds dissolve, that is, removes the color of your potassium permanganate. What is the reason? What is unsaturation? What is unsaturation in an organic compound? What is it? Yes, presence of double bond or triple bond. Presence of multiple bonds, if we have in an organic compound, those organic compounds are called unsaturated compounds. If we do not have any double bond or triple bond, those compounds, the organic compounds are called saturated compounds. Very good. The answer is very clear. And my question is, what is the reason behind the disappearance of color in the case of unsaturated compound? This is my question. If you don't know, I will tell you. The reason behind is very, very simple. Since we have a double bond in the unsaturated compound, you are adding bromine water. You are adding bromine. Let us assume you are adding bromine water. Bromine water, the moment you add and shake, there is a reaction taking place between the bromine and the double bond, that is carbon-carbon double bond, carbon-carbon double bond, where actually in these two carbons where we have a double bond, there is a reaction between the bromine. That reaction is called simply addition reaction. Simply addition reaction. Addition of, I can say finally that the addition of bromine across the carbon-carbon double bond takes place. Carbon-carbon double bond takes place. As a result, the carbon-carbon double bond now change to single bond. That is unsaturated compound now changed its phase into saturated bond. So unsaturation now gets changed into saturation because of the addition reaction between the carbon-carbon double bond and bromine. This is the reason, right? This is not the case of your saturated compound. In the saturated compound, there is no double bond presence, and as a result, there is no question of reaction between the saturated compound and the bromine water or your potassium permanganate. As a result, there is no doubt in it that the color of potassium permanganate or the bromine water, whatever you use, those color remains without any change, right? Pass one. Yes, please, listen me. Now I am going to demonstrate you how to prepare the sodium fusion extract. This is again an important step in your organic compound analysis. Without doing this, you can't proceed further. You can't carry out the presence of the conformation of your nitrogen, conformation of elements in general. You can't proceed without the help of this sodium fusion extract. Now for this, to do the sodium fusion extract test, you need to prepare sodium fusion extract, for which you take fusion tube. This is called the fusion tube. No need to introduce you the fusion tube. You are in the 3rd class this semester. Now one end of the fusion tube is open and another end is closed. Now you take sodium metal. This is your sodium metal, and this sodium metal is always kept in kerosene, not in water. Remember, this is highly explosive when it comes in contact with your water. Always this should be kept inside your under kerosene. So the solvent what we have is nothing but your kerosene, and the remaining is metal. You know very well that sodium is a soft metal, and I am taking a pinch of this sodium metal with the help of a pin, because the sodium metal is what I can say, this is wet, and this should be dried with the help of your filter paper or plotting paper. You dry it and take this a small amount of this sodium metal in your fusion tube in the first step. You take very little. Now see this, the fusion tube is now taken with, that is filled with your sodium metal a little. And to this, and before you take the organic compound into this, hold the fusion tube with the help of your tongue, nickel tongs, and now gently try to dissolve, that is melt down this sodium taken in the fusion tube. Don't show suddenly. Slowly you try to melt down the sodium taken in the fusion tube. Yes, already melted. Now you take little amount of your given organic compound. Again I am taking the given organic compound, a little, to this same compound is taken. Now try to, very smarter and this. You take little water into this. Now do like this. try to heat this fusion tube gently in the first step, and once you know the process of melting the organic compound taken place, you heat this strongly so that the fusion tube changed completely into red hot. See how I am dealing this particular preparation. Now almost red hot the fusion tube. Now plunge this into the water. Now this is your mortar. What is mortar? Mortar is a vessel that we use to grind the fusion tube, and this is called a vessel. This is the tool we use to crush the matter. Okay, mortar and pestle. Grind it well. In the meantime, you keep a funnel over your test tube with your filter paper. Grind it well.
எப்படி சார்
Almost grinding over. There is filter paper. Filter it. The extract what you are receiving after the filtration is called sodium fusion extract. Sodium fusion extract. This is the extract you are going to use to confirm the presence of elements in your organic compound. In particular, your focus should be on the nitrogen. I told you that the halogens and the sulfur part of your element we are not providing, we are not giving usually. Therefore, your focus should be whether the nitrogen is there in the organic compound or not. Now the filtration is over, and this extract now is called sodium fusion extract. Sodium fusion extract. Very simple. Take a little amount of the sodium fusion extract in another fresh test tube. To this add freshly prepared ferrous sulfate. How to prepare the freshly prepared ferrous sulfate? To this take extra amount of your ferrous sulfate, a new ferrous sulfate. To this add the water and shake it well. Shake it. Now the solution is ready. This solution is called freshly prepared ferrous sulfate. Now you add little of this freshly prepared ferrous sulfate into the test tube that contains sodium fusion extract. Yes. Now what to do is boil this and allow the matter to cool down first. Boil first. Allowed to settle down for some time. That is allowed to cool down for some time. Then once the cooling is over, then you add dilute sulfuric acid. Dilute sulfuric acid and see whether you get blue color or green color. Blue color or green color. Remember the formation of either blue color or the green color after addition of your sulfuric acid is purely because of the formation of complex. Formation of
complex.
Iron complex. Ferric and ferrous reacts with the cyanide, and the reaction is Sodium metal reacts with the carbon of your compound. Then the nitrogen present in the organic compound that will be converted into sodium cyanide in the first step. The sodium cyanide then reacts with the ferrous sulfate and it will be converted into corresponding compound that is complex. The complex is called the sodium ferrocyanide. Sodium
Ferrocyanide.
and after that you will get one more complex that is called ferric ferrocyanide, which is purple blue in color. Purple blue in color. Therefore you get either blue color or green color depending on the formation of the type of complex. Give me dilute sulfuric acid. Dilute sulfuric acid, please. Give me dropper tube.
Surya.
Remember, you can use either dilute sulfuric acid
Sir, H.
or dilute hydrochloric acid. Either you can use. No problem in using dilute sulfuric acid. You can use either HCl dilute or sulfuric acid dilute. Little hot, I feel. Therefore, you keep some more time. Wait for some time. Pass it. Now I am adding little of dilute sulfuric acid from your dropper tube. See the change in color. No blue or no green. Go ahead, little extra also. No formation of your blue color or green color. This confirms the given absence of your, in particular, with respect to out of all the elements given. I told you that our focus is on purely nitrogen. This confirms that the nitrogen is absent in the given organic compound. In the given organic compound. The same procedure you follow. If you have the nitrogen, please be careful. The procedure is very simple. You prepare carefully the sodium fusion extract. I told you how to prepare, how to handle all those glasswares and how to handle the sodium metal, why we keep the sodium metal in kerosene, why not in water, what is what will happen when we bring the, that sodium close to water, in contact with water, everything I have explained. What is the reason behind the formation of your blue colored solution or green colored solution? I told you the complex is formed. Everything I have explained. You please proceed and continue in the same manner with respect to your organic compound, what you have in your hand. Okay? Pass it. Please listen. I am going to show you how to carry out the confirmatory test on the presence of your carbohydrate. There is an important test to confirm the presence of carbohydrate in your given organic compound. The test is, with the help of the test, once you follow the procedure carefully, you will get finally a beautiful silver mirror. In your test tube. That is on the surface of your test tube, you will get the beautiful silver mirror. Remember, this is one confirmatory test. Don't think that this is the only confirmatory test. We have one more test. I will show you how to differentiate the same silver mirror test in the case of aldehyde also. You will encounter the same thing. Aldehyde also gives you the same silver mirror test, respond to the same test, and carbohydrate also gives you the same test. Anyway, I will show you how to carry out the formation of silver mirror in this test tube. For this, I am taking little of carbohydrate. That is given organic compound. I have taken in this. Now to this I am adding 2 or 3 ml of Tollens reagent. Remember, this is commercially available Tollens reagent. Don't use this reagent. the tolerance reagent you have to prepare in the laboratory. How to prepare the tolerance reagent? Anyway, I'll ask that is a laboratory assistant to keep the prepared tolerance reagent. Now try to understand what is tolerance reagent at this juncture. The tolerance reagent is nothing but ammoniacal silver nitrate. Its name is ammoniacal silver nitrate, wherein you are mixing ammonium hydroxide plus silver nitrate plus little of sodium hydroxide. Little of sodium hydroxide. A combination of all these three collectively called in the name of tolerance reagent. Tolerance reagent. Therefore, the tolerance reagent is otherwise called ammoniacal silver nitrate. Ammoniacal silver nitrate. Use ammonium hydroxide. To this add silver nitrate little, and then add a little of sodium hydroxide, mix it well. The complex, the product what you get is called tolerance reagent. Anyway, at this juncture I am using the commercially available ready-made tolerance reagent. Take extra. Yes, I have taken enough tolerance reagent. I am heating this gently. Oh, where is water bath? Heat this entire mixture over your water bath. Allow the water to heat first, then you place the mixture containing the organic compound plus the tolerance reagent. I have heated this water to some extent. The water is a little hot. Now I am placing this in the water bath and allow the water to boil completely. That is, let it heat completely. At least 80 degree. You maintain it at 80 degree or 70 degree so for at least 10 minutes. After 10 minutes is over, you take this and keep
Cooling.
to cool it down. And once the matter settled down, once the matter cooled down, you can see a beautiful formation of silver mirror on the surface of your test tube. This confirms the presence of carbohydrate, also presence of aldehyde. Now, since both the thing, that is aldehyde and carbohydrate, leads to the formation of silver mirror, now you can ask me how to confirm the carbohydrate, how to differentiate the carbohydrate from aldehydes. There is a simple test. The test is called Molish test. The test is called Molish test. And to this and before I proceed to explain the Molish test, there is one more test we have to confirm the presence of carbohydrate. Remember, what we do now will not show you respond with the aldehyde. The test is simply the treatment of carbohydrate with failing solution. Carbohydrate with failing solution. What to do in this failing solution test? You take failing solution A in your test tube and failing solution B in your test tube. You take one more test tube, the given organic compound, and dissolve in water. You take three different test tubes. In one, you take carbohydrate plus water, dissolve it. Because the given organic compound is carbohydrate, naturally dissolves in water. You keep the matter ready, and in another test tube, you take failing solution A, and in another test tube, take failing solution B. Now, try to understand what is failing solution A. I am using the technical name, the commercial name, the chemical name, failing solution A and failing solution B. Now, what is failing solution A and B? Failing solution A is nothing but pure copper sulfate dissolved in water. Its color is, this is your failing solution A. Recently prepared, just now prepared the solution. How to prepare failing solution A? you take copper sulfate in appropriate amount, you add water, dissolve copper sulfate in water. You know very well, copper sulfate is blue in color. You will get naturally this solution. This solution is called failing solution A, and this is your failing solution B. Failing solution B is normally colorless. What is failing solution B? Failing solution B is nothing but potassium sodium tartarate. And mixed with sodium hydroxide. This mixture is called Rochelle salt. Mixture otherwise called Rochelle salt. Its spelling is ROCHELLE, Rochelle salt. Rochelle salt is nothing but potassium sodium tartarate in sodium hydroxide. This mixture together is called as failing solution B. So keep failing solution A ready and failing solution B ready. Give me a fresh test tube. There is fat. There is carbohydrate. You take little of carbohydrate, you add water as I told you, keep this solution ready. This is test tube 1. In test tube 1, please keep it. You take another test tube. In this you take failing solution A. And you add failing solution B into the A. Then you add your organic compound that we have taken in the form of water. That is, after dissolution, we have taken this solution. You add together. The content we have taken here is organic compound dissolved in water plus failing solution A, that is nothing but your pure copper sulfate in water, and failing solution B, that is potassium sodium tartarate plus sodium hydroxide, otherwise called Rochelle salt, and shake it well. And after shaking, you keep this matter also in the water bath for heating. Now I keep the second also here. The first one we kept to confirm the presence of the formation of your silver mirror. With the help of that, we are going to confirm the presence of carbohydrate, and the second one also we are going to confirm the presence of carbohydrate. And once the carbohydrate is confirmed, we get red brown precipitate. This mixture will turn into red brown precipitate. This confirms after turning, which confirms the formation of the presence of your carbohydrate. Here, see the formation of your silver mirror. After keeping this in the boiling water, you wait for at least 20 minutes. I have taken this in 10 minutes or 8 minutes before. Now the time is after being kept inside, the time is just 7 minutes past. Due to the lack of time, I have taken this out of your boiling water. Anyway, the silver mirror, you can see the formation already started. This is a beautiful silver mirror. And the formation of this silver mirror confirms the functional group carbohydrate in your organic compound. And one more test is by mixing the failing solution A, failing solution B and organic compound in water and keeping at least for 20 minutes in the boiling water, you will get
silver mirror.
No, one more test. red brown precipitate, red brown precipitate. See here, the formation of red brown already started. This is again 10 minutes of time. Now I am very in a hurry, therefore I have taken this out of the boiling water. Anyway, you can see the formation of a brown precipitate, brown precipitate. This confirms again the presence of carbohydrate as functional group in your organic compound. And one more test, I told you that how to differentiate. I told you very clearly that both aldehyde and carbohydrate respond to the silver mirror test, that is the tolerance reagent test. Then how to differentiate? The differentiation is you go for the Schiff reagent test. You take the organic compound, add a little extra of a Schiff reagent, shake it well. A pink colored solution immediately you get when you get, if you get the pink colored solution after dissolving, after that is shaking the organic compound with the Schiff reagent, that confirms the presence of aldehyde. Remember, this Schiff test, Schiff reagent test will not respond to your carbohydrate. In that way, you can differentiate the carbohydrate from your aromatic aldehyde, right? So I have explained to you very clearly very important, crucial steps in your organic compound analysis. Number one is how to confirm. Most of the students commit mistake in doing the saturation and unsaturation. To be frank, the test to confirm the the saturated or unsaturated is very easy. But students are not following strictly the procedure that is given to the student, that is instructions given to the students. Once you follow strictly, you take little amount of the organic substance, then add a little extra of the potassium permanganate either or bromine water. In both, that is both are colored solution, both color will disappear. That confirms the presence of unsaturation. The disappearance of the bromine water color or the potassium permanganate color is because of the addition reaction between the bromine and potassium permanganate across carbon-carbon double bond. And the next test is aromatic or aliphatic. Take a little of aromatic, that is given organic compound, suspected organic compound, to be analyzed organic compound in a spatula, introduced into the Bunsen flame, blue edge of your Bunsen flame. When the organic compound catches fire, if catches fire and burns with a lot of sooty flame, that is with luminous flame, that confirms the presence of aromatic, otherwise aliphatic, Then I have explained later with the help of sodium fusion extract how to confirm the presence of nitrogen. You follow strictly the preparation of sodium fusion extract, and with the help of sodium fusion extract, add freshly prepared ferrous sulfate, then boil it by keeping in your water bath, allow the matter to cool down, then you add either dilute HCl or dilute sulfuric acid. While adding the sulfuric acid or dilute HCl, you will get definitely, if nitrogen is there in the organic compound, either blue colored solution or green colored solution. Otherwise, the absence of nitrogen you can confirm very easily. You can confirm on spot there is no nitrogen. And once you confirm the presence of nitrogen, you continue the analysis under the topic, the compound, organic compounds that contains nitrogen, You completely follow, you follow complete procedure. You do the analysis step by step. You will get, definitely you will reach the functional group present. And once the functionality is confirmed, then you start writing the procedure, starting from the preliminary test, then you write the saturation and unsaturation test, then you write aromatic or aliphatic test, then you write for the sodium fusion extract test, then you go for writing the functional group present. If the nitrogen is there, you write down only the compounds with nitrogen. All those tests, all observations and all inferences. Remember, while writing the procedure, while writing the the answer, the positive report should alone be written, not the negative report. For example, when you do the sodium fusion extract strictly, you will get either blue or green, not both, never both. Therefore, you write according whether you get blue or green. Some may get blue or some other may get the green. You write down whatever the color you get, right? You received, get while performing the test. And after writing, you write down after the procedure is over, you write down in the form of report, cleanly write whether given organic compound contains the following things. Number 1, aliphatic or aromatic, give a hyphen, then you write down the answer. Then write down saturation or unsaturation, write down your answer. Then you write down elements present. If nitrogen is there, write down nitrogen is present, and rest of the elements absent. And finally, you write down the functional group present, you write down the functionality of the organic compound given. If possible, write down finally the derivative of the corresponding organic compound given. Right? This is the procedure of starting your analysis organic compound and doing the analysis, and I have explained how to write the procedure, how to end up, close your write up, everything I have explained, right? And when it is the examination, when you are in the examination hall, you keep all the confirmatory test on spot, that is in the test tube, holder, and the examiner definitely visit you, and he may ask you to show the confirmatory test what you have arrived. And at that time you have to explain and you have to show the confirmatory test. Also you have to explain the procedure what you have followed. Okay. With this I am concluding this discussion. Thank you all.
Thank you.
Stop.